Hello, good day everyone. This is Group 7 video presentation. This topic is titled of different types of codes, binary numbers and integers with a theme of analysis of codes, binary numbers and different integers. These are group objectives. These types of objectives are concerned with the mental skills that are used for the types of codes, binary numbers and different integers for all students' knowledge. The use of types of codes, binary numbers, and different integers for all students' knowledge is one of those that will help them through competent communicators, engagement, and skill acquisition. So that the use of types of codes, binary numbers, and different integers for all students' knowledge will help speed up memory and they can solve them through the problem solving that belong to it. Before we will start or we will proceed the introductions, I will first show you the entire content or flow of the topics, which is the concept or framework. The introduction. We'll examine how computers operate in this topic, how to program them, and how to begin using fundamentals coding ideas. You discover the resources for our beginning coding sessions as well as practice exercises. Every digital computer employs the base 2 number system, or binary, which only needs 2 digits to encode information, carry out mathematical operations, and carry out logical control procedures. We're going to learn about a novel mathematical concept today. It is known as an integer.
Coding scheme is a convention that associates each character with character set with a unique bit pattern A, binary representation of the integers from 0. The common coding schemes are ASCII, ABCDIC, and Unicode. ACII, or American Standard Code for the Information Interchange, is a standard table of 7-bit designations for digital representation of upper and lowercase Roman letters, numbers, and special control characters in teletype, computer, and word processor systems. In short, the most format for text file in computers and on the internet. EBCDIC, or Extended Binary Coded Decimal Interchange Code, is the data encoding system developed by IBM and used mostly on its computers that uses a unique 8-bit binary code for each number and alphabetic character, as well as punctuation marks and accented letters and non-alphabetic characters. Unicode, or Universal Code, is the code scheme that is a new ANSI, or American National Standards Institute standards. It supports the most of the world's language and is becoming the internet standards.
And now let's move on to the next topic, which is the binary code. Binary code is a computer code that uses the binary number system, which consists of a string of consecutive zeros and ones. As you can see, this photo here is an example of a binary code. Those ones and zeros might not look like anything to you, but in binary code, the numbers are actually saying good day. Any code that uses just 2 symbols or represent information is considered a binary code. Now, when we say binary number system, it is a numbering system that represents numeric values in which there are only 2 possible states, the off and on, and usually symbolized by 0 and 1. The type of computer file used to store binary data is called a binary file. It could have any kind of binary encoded data, whether it's formatted or not. For example, a JPEG image is a binary file designed to be read by a computer system. The data inside the binary file is stored as raw bytes, which is not human readable. A binary digit, also known as a bit, is the smallest piece of data that a computer can process and store. A bit is constantly in one of 2 physical states, like a light switch that can be turned on or off. One binary number usually has a value of either 0 or 1.
Good day, I'm Jefferson Filio and I will be discussing the integers, bytes, and octets. So first is the integers of compute. Integers are numbers without a fractional component and don't support decimal points, while some programming language define these different types of numbers, others don't. For example, in C, you need to store the number 3 as an integer and 4.5 as a float. Second is integer and integers. As I said earlier, integers are numbers without a fractional component, and an integer is the number 0, a positive natural number or a negative integer with a minus sign. The negative numbers are the additive inverses of the corresponding positive numbers in the language of mathematics. The set of integers is often denoted by the bold-faced Z. And lastly is octets and bytes. In computer, an octet is a sequence of 8 bits. An octet is an 8-bit byte, and a byte is an unit of data that is 8 binary digits long, and since a byte is not 8 bits, in all computer systems, octets provides a non-ambiguous term. This term should not be confused with octal, a term that describes a base 8-number system.
Good day, everyone. I'm here to tackle about the following: the word, the short and long integers, the binary, octal, decimal, and hexadecimal system, and lastly, the binary number. First, let's talk about the word. The term word for a small group of bits that are handled simultaneously by a processor for a particular architecture. Now, let's talk about the short integer. The short integer can represent a whole number that may take less storage, while having a smaller range compared with a standard integer on the same machine. For example, short integer. Short A equals 12,345. Here, A is a short integer variable. Now, let's talk about the long integer. A long integer can represent a whole number whose range is greater than or equal to that of a standard integer on the same machine. For example, long integer. Long B is equal to 123,456. Note, long is equivalent to long integers. Now, let's talk about binary, octal, decimal, and hexadecimal system. Computer system regularly use numeral system of bases other than 10. Base 2 binary, base 8 octal, base 10 decimal, and base 16 hexadecimal. Numeral are used because designing a computer system is easier in this manner than for other bases. For example, base 2 binary represent any number using 2 digits, 0 to 1. Base 8 octal represent any numbers using 8 digits, 0 to 7. Base 10 decimal represent any number using 10 digits, 0 to 9. Base 16 hexadecimal represent any number using 10 digits and 6 characters, 0 to 9, and A, B, C, D, and F. Lastly, let's talk about binary numbers. In mathematics and in computing system, a binary digits or bits is the smallest unit of data. Each bit has a single value of either 1 or 0, which means it cannot take any other value. For example, 3 times 100 plus 2 times 10 plus 9 times 1 equals 300 plus 20 plus 9 equals 329.
Binary are represented only two symbol or digits, 1 and 0. We have 4 operations on binary and the addition, subtraction, multiplication, and division. Addition, we have certain rules to follow in adding binary numbers. Example, 110 plus 100. So 0 plus 0 is equals to 0. 1 plus 0 is equals to 1. 1 plus 1 is equals to 10. So that's the result. Second operation is subtraction of binary number. Again, we have the rules. Example, 11011 minus 1011. So 1 minus 1 equals to 0. 1 minus 1 is equals to 0. 0 minus 0 is equals to 0. 1 minus 1 is equals to 0, and just bring down the 1, so that's the result. The third operation is multiplication of binary number. We have also the rules, and let us apply it to the example. 1001 multiplied to 10, so the first digit of the factor is 0, so it is automatically all the factor is equals to 0, so we have 4 zeros. Next, we have 1 multiplied to 1 by 1 of the upper factor. Since we have multiplied it to 1, automatically it will equal to upper factor. So we have 1001. Then we proceed to addition and apply the rules of addition of binary numbers. The last operation of binary, the division of binary numbers. Example, 10 divide 10. First, let's see if the first digit can be divided to the divisor. The first digit is 1, can't be divided to the divisor. So we just put 0 on the top. And next, we have 10 divided by 10. Then multiply. 1 times 10 is equals to 10. Then subtract 10 to 10 is equals to 0.